Okay, so here we have question 10. A ray of light is incident on a boundary between glass and air. Which of the following is the refractive index of the glass? So what would you need to do straight away when answering this question? Well, you'd need to write out the formula relating this. So we'd go to our formula booklet, sine of theta 2 over n2 sine theta 1. So we'd use that formula over there. That's very important to be able to identify. Okay, so firstly, we always work with the angle that is next to the normal. So we would definitely be working with these two angles. We'd be working with theta 1 here and theta 4 there. So none of these, we wouldn't be able to we could straight away say that this one over there we wouldn't be working with because that's with 3, and this one over here. So it's either going to be between that one and that one. And now we just got to get the right ratio. So it says we're going from glass to air. So glass is related to theta 1. Is related to theta 1. So we're going to have that over there, and this would be our N1 over here. So that's what we'd be looking at. So N1, N2 would equal 1 because the refractive index of air we assume to be 1. Now we're going to have, this would be our theta 4 because this is going into there. So we would have that sine of theta 4 over the sine of theta 1. So it would be D would be the correct answer. Okay, if you need any help with working with those ratios, please come and see me about that. I can go through that with you again. Important thing though, identify your formula, and then I make sure that you know exactly where each one is, what each one is representing. So it says in this question over here that we have that it relates to this graph over here. Let me just make this a little bit smaller so we can see it all on one page. So we've got here, the graph below shows the displacement x of a particle undergoing simple harmonic motion. It varies with time. The motion is undamped. Okay, so it means that you're not going to be losing any energy with time. So which of the following graphs correctly shows how the velocity v of a particle varies with time? Now remember, this is a displacement time graph. So for a velocity time graph, that comes from the slope of the displacement time graph. So obviously here your velocity, the slope here is starting off at 0. So we'd expect our graph for this one to be starting off at 0, and because it straight away goes into a negative slope, we'd expect it to start off with negative. So in looking at that, only these two graphs start off with 0, and this is the only one that starts off with a negative graph, so it would be C would be the correct answer there. Okay, so we need to, obviously our basic understanding of displacement time graphs is important, and then understanding that the slope of our displacement time graph is our velocity, and being able to work with that would be important for that question. Okay, let me just move this down. Alright, going on to question 12. It says, which of the following graphs shows how the total energy of the particle varies with time? Now we know that as the potential energy and the kinetic energy both will add up, the EK plus the EP will add up to our total energy, and these vary, but they vary that this remains, the total energy remains the same for an undamped situation. So that is why 12D would be the correct answer for that. These may well be for for the potential energy. This one could be for the potential energy. These two could be for the potential or the kinetic energy. But when they add up together, they would give you your D. So this is the correct answer, D. Okay, going on to 13. It says an orchestra playing on a boat can be heard by tourists on boat Y, which is situated out of sight of boat and around a headland. The sound from X can be heard on Y due to. So we have all these different terms that you need to be able to work with, but so we have this because it's able to go around the headland like that. It's been able to go around. We would say that that is diffraction. So that is 13C. Now I think that is different from what it says on my solutions, which it says it's D, transmission, but yeah, I would say that C is the correct answer. I'll check up on that answer and see which make sure that I got that right. But I would say that C would be the correct answer there. All right, 14. This one, it says a graph shows how the velocity v of an object undergoes simple harmonic motion, varies with time for one complete period of oscillation. Which of the following sketch graph best shows the total energy E of the object? And again, we're going to get the situation that we talked about before. This would be C. Because it's undergoing simple harmonic motion, it seems like it's undamped, so the total energy would be there. So as at this point over here, you would have your E total is equal to your potential energy, because it's got zero velocity. At this point over here, all the energy here would be in your kinetic energy, and there would be no potential energy there. So it varies according to there, but leaving a total energy. The total energy would just be a straight line like that. Okay, they seem to like asking those questions. And then we go into 15. It says a force that varies sinusoidally is applied to a system that is lightly damped. Which of the following must be true of the force for resonance to occur? So if we read through these, it must always be in antiphase with the oscillational system. That is not correct. It wouldn't be in antiphase. It always needs to be in phase. So that's not right. Its direction must always be in the direction of motion of the oscillation of the system. Not always, no, because it would sometimes it would sometimes be in the opposite direction as the going away. If you're going towards the equilibrium. This is C over here is correct. Its frequency must be equal to the frequency of the oscillation of the system. So when the frequency of the force that's applied to a system is the same as the natural frequency of the oscillation system, then you get resonance occurring. And this doesn't need to be of the same amplitude. Okay, so C is correct one there. And then for 16, which of the following is the value of wavelength that is found in the visible region of the electromagnetic spectrum? I'm afraid you just got to know these values. It's a little bit rough, but you just got to know them. It's going to be 16, it's B. The range is always about 400 nanometers. Now, I mean, it's usually in a nanometer range, which is 10 to the negative 9. So you've just got to have an idea of that, know your electromagnetic spectrum reasonably well. And then 17, two waves meet in space. Which of the following properties always add together? So here we talk about interference. Interference of waves, and so it would be B. sorry, it would not be. The amplitude won't always add, because at that point it may not be. The amplitude is always your maximum. This is your maximum displacement from your equilibrium position. So that would be the maximum, but depending on where they meet, they may have different displacements. So it's going to be A. A is the correct answer for this. It's your displacements at that specific point of each wave will add together. Okay, so there's the multiple choice.